All right. Hello, everyone. Welcome to my talk on driving organizational sustainability with platform engineering. So before we continue, I just wanted to share a little bit about me. So I'm currently a tech lead at the New York Times, more specifically for the observability team, which sits under our wider platform engineering organization. And as someone who's responsible for the direction of our, I'm so sorry. I shared my own talk and this is what I get for it. All right, sorry about that. So before we continue, I wanted to share a little bit about myself, right? I'm currently a tech lead on the observability team, again, under a platform engineering org. And as someone who's responsible for the direction of my team and as an engineering leader across all of the times, I spend my time thinking about the function of platform engineering and how it can facilitate success across all of the times. And as someone who's responsible for this, this is where this sort of talk came from. And so before the times, I was also a platform engineering, and I was also a platform engineer. And so this talk is just a compilation of the consistent approach that I bring to each of my roles. And ultimately what that looks like, is coming, is coming from the perspective of enabling our department to work in a way that ensures long-term organizational sustainability. And so we'll start off by talking about what we even mean when we say organizational sustainability. There we go. More specifically, I define sustainability as the continuous practice of operating in a way that enables short-term growth opportunities while ensuring long-term success. And so there's a lot to unpack here, so we're going to break it down a little. And so first, sustainability is a continuous practice, right? Even if you spend a lot of time upfront thinking about how to ensure long-term sustainability, circumstances change often quickly. And so we need continuous avenues to ensure long-term success. Second, enabling short-term growth opportunities. And so sometimes those risky short-term growth opportunities are what lead to our long-term success, right? The emergence of bundles of tools has worked really well for some companies, including the Times. And so we don't want to give those up, right? But putting on my liability engineering hat, we also need to make sure that we are prepared for the risk of those opportunities, which leads us to the component of enabling long-term success. And so we frequently see companies take their core business for granted in the name of growth. But for every successful growth opportunity, the thing we don't really like to say is that most opportunities fail, right? Companies with a strong product vision and often neglect its maintenance and modernization to focus on these new opportunities that are potentially a large source of risk. And so preparation for this risk is essential. So now that I've defined the goal, which is organizational sustainability, let's define the strategy, which is platform engineering. And so as much as I hate repeating words on a slide, I'm going to do it, if only for emphasis. And so my definition of platform engineering is platform engineering drives sustainability by practicing sociotechnical principles that provide a community-driven support system for application developers that are using our standardized shared platform architecture. And so these three components highlight what forms the basis of what it means to provide a platform. And so one theme throughout this talk will be about how platform engineering can also enable us to scale our organizations. And so as part of that, right, we need to ask ourselves, at what point is this platform engineering framework even necessary? And so we'll frequently talk about scaling software, but what does it actually mean to scale an organization? And the answer to that is ultimately that our ability to scale our organization is directly tied to our ability to scale our software. And when we think about scaling our software, right, we have to be intentional about addressing the inevitable drift that often comes with this. And we have to be intentional about how to go about that. And so to address this complexity, we have to bring this intention into how our architecture can enable those needs. Now, because complexity makes development so much harder, right, we as a collective industry have evolved the way that we build applications, right? For example, the modular monolith has become an increasingly popular architecture style, especially as an intermediate step towards adopting distributed architecture patterns that eventually enable us to work with and scale our applications. And so just like we've evolved the way that we build applications to embrace new architectural patterns like microservice architectures, we must evolve the delivery strategies that we use to build these new architectural patterns. And so if these architectural patterns are a solution to the technical complexity of scaling our applications, platform engineering is a socio-technical solution to the organizational complexity of scaling our applications. And so to summarize this kind of nicely and concretely, platform engineering is a socio-technical solution to the organizational complexity of scaling our applications. And so we'll spend the rest of this talk decomposing each of these components from earlier, the principles that guide us, the community-driven support that enables application developers, and the application and the architecture that we use along the way. So first, we have the principles that guide the rest of our platform. And so having focused on reliability management, the principles that we'll review are heavily influenced by DevOps, particularly because DevOps principles take a strong consideration for both the technical and social components of what it means to develop and operate software. And so we'll head into those principles next. So some of us might have heard of the COMS framework, which was coined by Jez Humble, who's a co-author of Accelerate. And this is basically a framework of principles that should be the core of DevOps organizations. And now, while all 5 could be easily applicable here, we're just going to focus on 3, more specifically, culture, automation, and measurement, because that makes it CAM, right? And so starting off with culture, the COMS framework tells us that it drives a culture of continuous improvement and reduces silos by intentionally sharing knowledge and feedback. And you can note that while we removed the S here for sharing, its presence still shines through this principle anyway. And the same is true here with platform engineering, though I'll talk about it more concretely by putting it in the context of community. And so in DevOps, we often talk about breaking down silos. That's actually the problem where DevOps really emerged from. And the way we bridge that is by sharing knowledge. And to share knowledge ultimately means to connect. And so connection and communication are going to be key for preventing silos that would hinder our ability to make this continuous progress. And so when we're talking about organizations, especially as our organizations grow, the most effective way to not only manifest this culture of sharing, but also to improve employee engagement and retention, which are other ways of ensuring sustainability because turnover is expensive, is to also think about how we can cultivate a strong community that fosters this at scale. It's because ultimately, right, the opposite of isolation is to be in community with other people. And the reason that's so important is because more than anything else, right, learning is our most sustainable advantage. And this quote is by Andrew Clay Schaefer, who is often known for being the co-founder of Puppet, and he recently said this in his talk about socio-technical systems at DevOps Days Amsterdam. And the way I interpret this to mean is that because our industry is constantly changing, being able to keep up with this change is the biggest advantage that we can give ourselves. And to do that, right, learning needs to be a part of our organization's DNA. And so now, while I agree with him, I'd like to modify this a little bit to emphasize that communal learning is actually the most sustainable advantage. Because while our individual growth is important, right, if we're not sharing knowledge intentionally, we risk introducing singular points of failure. Right, humans are not that reliable, and nor are we supposed to be, right? We're not supposed to be 100% reliable. And community, right, provides this sort of redundancy and ability to sustain both ourselves and our business. And so as an industry, right, we need to stop incentivizing engineers to engage in this behavior because ultimately people respond to the incentives of the systems that they're operating under, right? And sure, you know, individual responsibility is a part of this, particularly for smaller companies and for those of us who are in management or leadership positions. But a culture that cultivates this behavior is far more dangerous than any of the individual engineers that are participating in it. And if you have a low trust environment, which many companies do because that's the nature of capitalism, getting there is not easy, right? Especially right now because our industry is really just not doing well with trust, right? Because of these short-sighted decisions like return to office, layoffs, right? Benefits being cut off, etc. And I could keep going down this train of thought, but we don't have 3 hours. So I will move on to the next point. And so next we have automation, which improves our software delivery process by reducing human error, improving our efficiency, and enabling faster delivery. And so this means thinking critically about the type of work that doesn't require business-specific knowledge. and figuring out whether that work can be consolidated into software that's managed centrally by platform engineering teams, right? And in this, right, we get to reduce the cognitive load that product engineers would have to take on by indulging managing all aspects of their software. And the type of work that's important but can be centralized is in an automated or centralized way is often work that's repeatable or manual, right? Which SRE often refers to as toil, or what product engineers might actually refer to as like boilerplate software. Another aspect of platform engineering is how we should be explicit about improving efficiency by leaning, no pun intended, because that was another one of the one of the words in this framework, but by improving efficiency by leaning into solutions that are built by third parties, whether that's a vendor solution or open source solutions. And the reason for this is because as much as we need to reduce the cognitive load on our product engineers, we also need to do it for ourselves, right? A lot of work can require really deep subject matter expertise, whether that's to manage infrastructure or build CI/CD pipelines, or build runtime frameworks. And so reinventing the wheel is not supposed to be the inherent function of platform engineering, no matter how tempting those really nice technical challenges might be, right? And I do kind of blame some large companies for this, for setting the precedent to build everything in-house. But at the same time, right, for them, that might actually be genuinely necessary. But for those of us who are in our earlier stages of our engineering stories, that shouldn't be our first instinct. And again, the reason for this is tied to sustainability, right? Hiring for these very specific skill sets is hard, right? And people often leave. And so the question we should be asking ourselves every time we develop a new tool is what would happen if this engineer who developed it actually left, right? We've all been there. What if my business was at risk and I had to heavily prioritize our work towards growth opportunities, right? How much would the maintenance of that be considered a burden versus a genuine value add? Now, I would be naive to not mention the issues of vendor lock-in that often emerge by relying on vendors, which is why I think paying close attention to open standards and open source is an underrated skill set for platform engineers. And so using my domain, observability, as an example, we've had this issue with vendor lock-in a lot. And that's often because there's so much drift in the space. But with the emerging open telemetry standard, which targets this exact same problem, we're able to move away from that and move away from being so couply tied to our observability vendors. And so I mentioned that not only because we should keep that in mind for our own work, but also because it can be really good tool evaluation criteria, right? Asking and answering questions like how a given vendor supports the standards in their domain can be very telling of the type of user experience that they want to cultivate. And again, right, to use observability as an example, some of the things I ask myself to determine whether it's a supportive vendor include like how much vendor-specific code do I have to write? Are they contributors to the open standards, right? Do their cost models encourage or discourage using the standard? So as an example, right, some vendors treat all metrics emitted by OTel, OpenTelemetry tools as custom metrics, which with their own specific cost model that can lead to substantial amount of cash spent. And again, just to elaborate on my point about open source, it also presents an opportunity to practice good industry citizenship, which I really wish we would think about more. And we do this by contributing to our open standards. And contribution takes many forms, right? It's not just code contributed. It also means providing feedback on use cases, reporting bugs, documentation, evangelizing the work, et cetera, et cetera. And lastly, we have measurement. So first, let's talk about what the point of measurement even is, which is ultimately that to provide feedback loops to determine whether our work is actually having its intended impact. And so these feedback loops should consist of both qualitative and quantitative feedback loops for continuous improvement. And the way that this connects to sustainability is, again, by eliminating the time spent on work that doesn't ultimately lead to our business goals. So for example, right, if a tool that we spent weeks on, perhaps even months, isn't actually serving our product engineering organizations, which leads to lack of adoption, we've now invested time that we could have actually just directly used for serving our paying end users. And so we end up missing the ultimate goal of building applications that age well with our evolving product growth opportunities. And so in other words, these feedback loops keep us on the right path towards continuous improvement that will enable us to build new features while maintaining our existing software. So now that we've defined our principles, we'll shift over to talking about support strategies for application developers that are integrating with our platform. And so we'll speak to both scalable and flexible strategies and put it in context with the ways that we measure success, consolidate efforts, and cultivate a culture that values sustainability. And so the first is the most scalable strategy of all, which is to make building software, sustainable software easy. Probably not that surprising, right? We'll deep dive into this one more in the next section where we really dive into like platform architecture. But just to set the stage for that a little, let's remember from earlier that sustainable organizations are directly tied to their ability to build sustainable software. And so again, what we mean by that is software that ages well with evolving business needs. And so I'm sure we've all worked with software that clearly wasn't built with much foresight, right? This is usually what we end up referring to as tech debt. And tech debt is inevitable, right? But we can mitigate its risk by being intentional and strategic about when and where we actually inject that tech debt. And so tech debt should ultimately have a function, right? Which is usually for the purposes of growth opportunities. And so tools that aren't easy to integrate with are a type of technical debt that typically doesn't pay off in the long term. And so it's especially as our duty as platform engineers to build, easy to use tools to minimize the time we spend needing to actually support application developers. So now, that's not to say we shouldn't be willing to support developers, right? The opposite is true. We just need to be intentional about when the right time to support is and how we can leverage a culture of communal learning and support so that we're not the singular points of failure that I mentioned earlier. And so not only does this alleviate some of the tension on us, but it enables us to be community driven in the way that we support product engineers. And so we talked about measurement as one of our principles. An important measurement of our effectiveness, as I mentioned, is the adoption of our developer platform. And so what this intention looks like here is ultimately defining the ways that we approach support and clearly communicating it so that we don't have mismatched expectations that will degrade trust between platform and product engineers. And so in the interest of time, I'll only provide one example of this, which is to provide an easy decision framework that's driven by the status of your tool. We don't have enough time to review this, but feel free to take 3 seconds to take a picture because I need to drink water. All right. So a common pitfall for platform engineers is to take on too much integration work. So like the last slide showed, there's room for that, right? Especially in the early experimental mode. But that's not a scalable software. That's not a scalable solution, especially for those of us in organizations that are particularly large. And nor are we often even the right people to be doing that work, right? Relatable example here might be like testing. Platform engineers can certainly create or recommend testing tools or methods, but we can't ultimately be the ones that are writing like their unit tests, right? That requires domain knowledge. And luckily, if we're doing our jobs right, the time that we save by supporting them frees up their time to actually take on that application-specific work. And lastly, driving a sustainable culture. And so sustainability, as I've said, doesn't just apply to software, it applies to people, and the two are very closely tied. And so referencing Accelerate again, it talks about self-sustainability and the different types of burnout to look out for, whether that's physical or emotional, etc. So I've been on product engineering teams before. That's actually how I started my career. And the reality is that their work is often higher stress, right? While we have the very real challenges of getting buy-in, that our work is actually important, which is why I wrote this talk to begin with, our pressure is often indirect. Right? And so I found it easier to lean into like my leadership and serve as an example of what it looks like to operate in a way that achieves excellence without sacrificing people along the way. And so our work is going to be naturally collaborative because it'll touch many, if not all, points of our organization. And so we should drive this sort of culture with everything that we do. And lastly, we have our platform architecture, which is the architecture that platform engineers are building to support application development. And so this is where the nice like technology part that I'm sure you all have been waiting for is. And so again, right, the function of our architecture ties directly to the first support strategy that we talked about, to make building sustainable software easy by consolidating the efforts and cognitive load centrally. And so we've talked about our high level principles. And so next we're gonna focus on architecture design principles. And so the first is to embrace design-driven architecture as our core principle. To my final point before, we have the privilege to move with more intentional design. And this intention is what enables us to minimize the technical debt and risk that leads to this lack of sustainability. And this principle can be broken down into many pieces, but I'll omit that for now because we'll talk about design tensions and how to alleviate them in a few minutes. Secondly, our architecture should be complementary to those of our users. Now, that doesn't mean we shouldn't try to anticipate developer needs. There's definitely a value in thinking about where our platform architecture might be heading, but to the last principle, right, we need to design with the future in mind, not necessarily built for it immediately, as much as it's tempting, right? And we do this much in the way that we might design a monolith application in a way that would enable us to decompose it to a distributed architecture in the future, right? We don't start off with microservices, hopefully. So when we prioritize our work, we should be driven by the needs of our application developers that are in our organization, whose architecture we should assume are a reflection of their end user needs. And so that is why platform engineering should be a steady rather than a fast evolution. The way that we organize ourselves and prioritize work should be grounded in the reality of the types of problems that product engineers are facing. And so that's why companies in the earlier stages don't necessarily need a platform team. It's often too soon to even be able to make accurate and thorough decisions on what problems to solve for. And that can lead to like potential consequences that we talked about earlier, like building tools that lack adoption. But as you grow, the themes will naturally emerge, and those are what will actually make a genuine difference. And so that might lead to prioritizing certain domains, whether that's CI/CD or observability or runtime language support. And within those domains or problems you're trying to solve, you also need to build in a way that's responsive to evolving architecture and developer needs. And so, for example, if we want to improve our runtime experience for developers, we should prioritize the languages that are actually used by them, not the ones that we want to support first, right? And so, right, because ultimately we're not here to tell developers what to do, we're here to support them in what they need to do. And another reason that this is important is because our platform architecture can lead to what I call platform chaos. Yeah, and so an overwhelming number of tools, especially custom ones, is not the goal, right? Tools should just be enablers of our goal to build successful engineering organizations. And so instead, we need to be managers of chaos, which leads me to the design tensions I mentioned. And so first, we have what I think is the hardest one, the balance of standardization versus flexibility. Right, the shared nature of a developer platform is an awesome opportunity to reduce the risk of drift, but we have to hold that intention with the flexibility that developers might need, especially as our organization grows and the number of technical needs grows with it. And so, for example, right now, my organization is facing the consequences of building tens of services with this really opinionated framework that has since not aged super well. And so now, not only do we need to revisit our approach to that, to runtime support, but we also have to reconcile the tech debt that manifested from this decision years ago. And so that said, reflecting on where we went wrong, but what we're doing now is to engage with our users more. Pretty straightforward. And so I started this talk by saying the opposite of isolation is community. And so now we're also approaching it from that standpoint of driving standard definitions with actual teams and our learning communities of practice. Next, we have the tension of simplicity and complexity. So as you respond to the evolving needs of your users, complexity is going to be harder to manage because architecture that supports them is likely subject to change, whether that's to begin using event-driven communication styles or begin embracing client-side rendered front ends. And so this becomes another area where we need to be intentional about, right? Because like tech debt, complexity is inevitable, but we can compartmentalize it somewhat by making sure that our developer-facing interfaces are simple. And so, which leads us to the most common source of complexity in software engineering, which is integrations. And so we know the common design principle of reducing coupling between services, right? And the same applies to our work. Integrations are high risk because avoiding coupling is incredibly difficult. And that's why a huge selling point for vendors is often their integrations. But these integrations are also what lead us to lock-in that I covered earlier. And so speaking of vendors, right, remember our automation principle earlier? So even though I just spent some time talking through design principles for building platforms, I also want to say, like, give yourself permission to not even build it at all, right? Decision to build versus buy versus reuse should be our bread and butter. And deciding that we don't want to take on the work of building and maintaining a tool is a very valid one, because every line of code you write is a liability. And so code isn't supposed to be our bread and butter of platform engineering. Research, design, and technical decisions are. And so, like I mentioned earlier in the principle section, we do have to worry about vendor lock-in. And so I'll emphasize the point that we should also be paying attention to how our industries are defining open standards, like OTEL, open SLOs, etc. And so holding all these tensions in mind, let's talk through what I call the platform recipe. And so this recipe is a reusable framework with 4 pillars. These allow us to enable, compartmentalize, or communicate the trade-offs of the tensions that I just talked about. And together they make up the ultimate platform architecture. And so we'll briefly review these, each of these pillars, and then provide some concrete examples. And so first, we have the parts of our architecture that provide standardization. 2 examples of how we might do that is through templates or opinionated frameworks. Secondly, we have the parts of our architecture that provide more flexibility. So for example, we might modify our framework to become more modular so that developers can actually pick and choose based off their context. And so we might also extend the way that we do templating by providing a CLI or something to make them dynamic. And thirdly, we have the parts of our architecture that compartmentalizes complexity through integrations, since those first 2 pillars are the simple interfaces that I mentioned earlier. And this might be APIs to tie the 2 pillars together, or plugins into front-end interfaces that developers use to provide visibility that they even exist. And so these tools are often not directly actually used by developers in their development, and are instead tools that we use to support developers in a more automated way. So for example, the tools that pull our technologies together to support on-demand environments, right? Engineers are certainly going to use the environments, right? But the technical details of how we implement those should be abstracted away so that they can focus on product development. Lastly, we have the parts of our architecture that communicate our design and decisions along the way, whether that's API docs or decision records for when we decide to build, buy, or reuse. And so it might feel a little strange to have this considered be part of our architecture, but as I've emphasized throughout this talk, right, our touch points between platform engineers and product engineers is essential. And so especially in a work that's embracing remote work, right, software is going to help us facilitate that. And so documentation is the first obvious one, right, with perhaps support channels as a complementary. And there's also a potential need for automating certain aspects of support as we scale up the number of engineers that we're supporting. And so for example, right, if your primary communication tool is Slack, integrations that consolidate questions and feedback centrally can enable us to have more feedback loops that can be really valuable to avoiding adoption issues. And so in the integrations pillar, I mentioned that plugins as an example to provide visibility that our tools exist. And that's an essential question to answer because visibility is needed to drive adoption, right? And so we'll answer that question of how to provide visibility into our architecture. And so especially with the emergence of Backstage, which is an open source project created by Spotify, developer portals have become a way to provide centralized visibility into our developer platform ecosystem. And the concept of a developer platform portal is compelling. It ultimately tells the story of what it means to develop software at our companies. And so by providing this unified view, not only does our platform become visible, it also facilitates visibility into any service that's actually using that portal. And so integrations are a crucial part of developer portals, right? But because it's a centralized entry point, we do want to consider the risk of a singular point of failure. And this is why they embrace plugins, which are designed to be easily added or removed from the host application without total coupling. And so in other words, it provides similar benefits that we see with microservices by having concrete separations of concerns. So I mentioned how developer portals tell the story of what it means to develop software at your company. And I want to give a little bit more insight on what I mean by that before we go into those concrete examples that I've been promising you all. And so in the interest of time, I'm not going to go through each of these stages. All you really need to know that this is the story that we're trying to tell, right? The one around our feature development cycle. And the ones that are most relevant to us here are development, production readiness, and release stages. So those are the ones that we'll focus on for the rest of our talk. And so note that the examples that we'll see here aren't the solution, they're a solution. Most of them are on a naive side, right? But the concepts remain the same. And so starting with development, which supports the end-to-end development cycle, particularly runtime and architecture needs, we embrace standardization here, the first part of our recipe, with runtime templates, which minimize repeatable code by centralizing it into a template. And so what this looks like practically might be a server file like this, right? This template not only provides a reusable file, but it also can act as a standardization technique by including our organizational framework of choice, which in this case might be Express. And so from this, right, developers only need to modify the parts that need service context, which I highlighted here. And over time, right, we could also extend this template to also include standards for other tools and dependencies like package managers, linters, testing frameworks, etc., which we could reflect with like a template JSON config file. And when beginning to build out these templates, right, we should start simple and build our way out. Rushing into the development too quickly can lead us towards a path where we're building a developer story on golden paths that don't actually serve the needs of our users. Alternatively, we might decide to build a runtime framework that codifies our organizational standards. And so you can imagine that as your organization grows its standards, that this template file may become really, really overwhelming quickly. And so, for example, right, we could extend our functionality to include middleware or standardize how we write APIs. And as we add more and more of this code to the template file, it's probably going to become impossible for developers to figure out what's being provided for them. And sure, comments can help, but there's a reason that we like to use abstractions in software engineering. And so in an effort to keep that template simple, we can abstract the details away and replace our Express code with our own framework that still uses Express. And so here's what our package code might look like, as well as a simpler server TS file that we would now be providing. And so there are, of course, many downsides to this, right? This is a fairly large dependency introduction. I mentioned earlier about our framework that we're now having to reconcile, right? We're going to have to maintain it for this code for years. And it's a commitment that we really shouldn't be making lightly, right? And it requires a really large amount of intentional design. But it can address drift a lot more effectively because templates are easier to change, right? Since the internals of the code in frameworks isn't one that they own. And so this is one of the classic trade-offs of engineering. And so now that we've seen frameworks primarily, now I've seen frameworks primarily work for organizations that adopt platform engineering. Sometimes they call it a different name on the earlier side, more specifically during that sort of transition period where we've decided that a monolithic application is not working for us anymore, and that decomposition is just part of our reality. And this is because once we're already down the path, down the distributed systems journey, addressing drift with the framework is really tough to justify to service owners if their service is frankly working for them, right? And because of this point, the service was probably already built in an opinionated way, and so reconciling all that drift in software and opinions is often a really tedious process. Engineers are really opinionated, so the earlier you start, the better off you'll be. But if you start to build out a platform before you're too far down the rabbit hole, right, it actually can set us up well for successfully decomposing a monolith, since the repeatable tasks like making our service observable that we would need to do for each service can just be abstracted into that framework. So pros and cons, that sort of timing is really what makes a difference here. Now, when frameworks aren't the right path forward for our organization's needs, but we still want to provide some flexible options, right? Runtime packages are a great tool in our recipe. And here we still have a lot of decisions to make, including where on the spectrum of flexible we want to be, since packages are still an opportunity where we can inject standardization. So to ground this into an example, we might have this function in a package, and this header might indicate something related to authorization that we want to have a standard for. Naive example, and probably a security risk, but it's best I come up with. The standard, in this naive example, the standard is that we want to have a header value be all uppercase, right? And while this function is opinionated, unlike a template or a runtime framework, this functionality is opt-in, right? Meaning that while we want to incentivize developers to use it, we can't really require them to use it. And again, the goal here is to save developers the time that they would have been spent writing this code themselves. And so saving this time in for a relatively few number of developers might not be that impactful, but as your organization grows, you can see that the time building libraries can be paid back in the long term. And so an additional benefit of packages is that that if you ever want to revisit the possibility of building a centralized framework, you already have some of the building blocks that you can use to assemble the ultimate framework. And building modules is often a really great step first also for adopting platform engineers, especially those who have already sort of gone down the distributed systems route, because it allows us to incrementally build for the needs of our developers without investing a huge amount of time and effort that a full-fledged framework might require. So now we move into our next pillar of the recipe, integrations and plugins. And so extending on our example, as our organization grows and our architecture needs also evolve, so might the number of our packages, right? This was the second principle that I mentioned earlier, architecture principle. Developers will need visibility into the different types of packages that we offer. So naturally, we'll probably decide to want to integrate with a package manager, which would be managed essentially so that it has clear ownership and so that it doesn't become too bloated with packages or artifacts that like our templates. And conveniently, there might even be a plugin available for our developer portal so that it's even more visible. And along the way, we'll need to document our work so that users can use our tools smoothly. And so combining this with our second architecture principle from earlier, finding ways to automate this will make our lives a lot easier and set us up for our docs to be less stale. So for Node, any of you who are Node developers, this might mean integrating with TypeDoc to automatically generate them, which might then plug into your developer portal to render the actual docs there. Now, skipping past the production readiness step for reasons that will be clear later, next we have delivery, which supports software development by focusing on infrastructure management. So similar to our last example, we can embrace standardization through configuration templates. And these might be completely static or use templating syntax if you've ever used Helm or some equivalent. So for example, for our example, we'll say we use Helm, we decided to use it to minimize a surface area that developers need to interact with, which keeps it simpler and subject to less human error. And so what this might end up looking like is something like this. And so here we've provided two YAML file templates, one that represents a Kubernetes deployment and the other one that represents the values used for that deployment file. And so now developers have less config to manage their infrastructure, right? And the main thing that they have to worry now is that values YAML file. Next, we embrace flexibility through a similar technique that we saw from earlier, modularization. And so we see similar benefits as we did in the development example, new flexibility that enables engineers to pick and choose which modules make sense for their actual needs. And it also makes it more maintainable, especially if we extend our platform to embrace a chart generation integration, which we can also do in an automated way by setting up a build or deployment pipeline that performs this process. And so here you see a new YAML file, chart.yaml, to set up chart generation. And during this process, that values file gets copied into a service repository, from the service repository into the chart generation repository, which replaces a placeholder file. And so using a Helm specific CI/CD tool, our pipeline then can generate the Helm chart package based off of those files. And this makes change management easier, especially if you build visibility into the process with observability. And lastly, even though infrastructure details should be abstracted away from product engineers as much as possible, there are decisions here that they have to make because they have to be made with context that's specific to their services. And so we saw a values template file a few slides back. And while we can provide those strong defaults, these defaults likely won't work for any given service using those defaults. And so not only do we need to provide context on how we choose those defaults, we need to provide documentation on when those values need to change and how to go about making those decisions. And lastly, we have production readiness, which supports the post-delivery needs of software through production readiness techniques. And this work often builds on top of the examples we just saw. For example, we might extend our configuration templates to include features that enable reliability. And so again, observability is my focus area, so I'll ground it in an example from that space. So let's say that we have decided to use Open Telemetry standard after considering the trade-offs of defining our own standard, using one from open source, or a vendor-specific one. Given decision, we choose to embrace standardization even further by adding a new config in the values YAML file to support the standard. And so now developers don't actually have to worry about managing the config needed to use the Open Telemetry collector. Instead, they can focus on instrumenting their applications for telemetry that requires service context. Now, switching gears into the runtime packages, we can also extend that development experience to include modules that provide features relevant to reliability management. Again, observability. And so this might mean providing optional middleware function to enable telemetry collection. And so in this very naive example, we see a similar attention as earlier, where we standardize the key of an attribute to provide flexibility of managing the value through environment variables. Now, I mentioned that our work needs to align with the needs of our product engineering peers. And so let's say our product has become really successful. We are solidly in the distributed architecture space. And some of our product teams have new technical requirements that require them to be very careful about performance implications. And they need strong concurrency support. And so our organization decides to introduce a new standard language, Go. And this makes our lives as platform engineers harder, right? We now have to support another runtime language. But we shouldn't meet with this with too much resistance, right? We can provide feedback as peers, absolutely, because perhaps the decision does need some pushback. But being dogmatic about our golden path too much isn't a recipe for success either. And so that said, let's say we do have to start thinking about Go development. And so going back to our observability example, that means we also need to think about telemetry, what telemetry collection looks like for Go. And we already use Open Telemetry, so we want to reuse that decision for the sake of consistency. But then we come across this, currently work in progress. Yeah. So what do, right? We know telemetry collection is important. How else are we going to debug our production systems, right? And so do we rely on older methods of collection, manual instrumentation, vendor-specific agents, etc.? And so, that can be one valid conclusion and probably the most practical. Frankly, but I'll take the opportunity to still give a nod to open source. One of the three options that I mentioned in the build versus buy versus reuse tension from earlier. Whoa, sorry about that. There we go. Cool. So our second principle talked about the role of automation in our work and how one form of that is to reduce the duplicate work that often happens in engineering, right? And more specifically, I offered the solution of deciding when to build versus buy versus reuse. And part of the reason for that is because we'll end up spending unnecessary time reinventing the wheel, but also because we have to admit to ourselves that a lot of times other people are going to do it better than us. And admitting that doesn't make us any less of an engineer. In fact, it shows humility and appreciation for the work of our peers. And it provides an opportunity to learn from each other. And so we can't be experts at everything. Engineering is an underrated way to build community, right? And so it doesn't have to be isolated to your company either. And so bringing me back to the observability example, knowing that it's a really exciting time for observability, the observability space and many more spaces, we know that there are also really smart people thinking about this already, and clearly there's so much to learn and work on, right? And so community-driven support was a central theme of the previous section. And so don't try to learn and build this in silos, right? Learn and contribute to the communities already doing this work so that you can benefit from their past and future work. Because as much as the sustainability of our organization is about our ability to build sustainable software, the sustainability of our organization is about the industry's collective ability to learn together and make progress together. So moving on to the third part of the platform recipe. The one thing I didn't mention with OTel config example, is that it also reuses the decision to integrate with Helm, which has the added benefit of making the interface for developers simple, by again, abstracting those details away. On top of this, however, we can use emitted telemetry, more specifically metrics, to enable automated rollbacks in our CI/CD pipeline for when we release a bad change. And lastly, all these different components and decisions can quickly get overwhelming, even if we're designing with a lot of intent. And so not only do those decisions need to be reflected somewhere, we need to understand that infrastructure incidents are also ours, right? And that the process of incident management should be one that fosters collaboration and knowledge sharing, which is a value that is reflected in our principles. And so what this looks like can be a little tricky depending on whether you have an SRE org and their specific operating model, but regardless of the structure, driving clarity of over what incident support looks like is crucial to avoiding broken trust when our platforms inevitably fail. All right, so now that we've talked through the three components of our platform, we're gonna put this all together. And we'll do this by framing it through the lens of our feature development cycle from earlier. And more specifically, we'll approach this from the lens of a life cycle of a service, focusing on the flow that might make up what we usually call a golden path. And so starting from the left side here, let's say we're building a new service, a new backend service in an organization with a fairly mature platform. And so to get started, we enter the developer portal integrated with an artifact manager, select a bundled standardized service template, enter details like service name, and then an API integration that platform engineering owns generates a service using an integration with GitHub. In the beginning stages of our platform, we might only have one golden path for development cycle, but over time there might be multiple decision points for developers. And so perhaps the decision to use a framework-based template over a module-based template, or to not even use one altogether. And so as a support system, platform engineering should also be available to consult and guide product engineers throughout this process. And so now we're ready to develop our service. Depending on our development needs, we can utilize even more modules or use framework features. From there, we'll continue to use GitHub either directly, but now also through a developer portal integration until the PR approval process is done. Insert caveat that this stage isn't quite so isolated from the rest of the life cycle here, and so from there, we can enter the delivery focused part of our platform. So that bundled service template that we use to generate the service also includes config templates that the CI stage can use to build, test, and perform static code analysis. And so now we only have to worry about choosing good values and modifying the values YAML file. And since our portal also includes a drone integration, developers can get visibility really easily into each of these steps, which is especially useful for when they fail. And so if that CI stage passes, a CI integration then pushes the build artifacts that were generated in the CI stage, providing access to the rest of our stages in our pipeline. Again, the developer portal provides visibility through its artifact repo manager and their drone integrations. And so those artifacts would be used during the continuous deployment, to perform things like infrastructure management, pre-production testing, etc. And so using GitHub or the portal integration, we move on to the tasks related to release management, like approvals, release tagging, release documentation, etc. And so after successful testing and approvals, the service is deployed to production using similar mechanisms as a CD stage, but with additional safeguards like automatic rollback features that we mentioned from the production readiness example. And finally, we've concluded the delivery process and head into maintenance mode, which is supported by the production readiness tools that we provide to observe and monitor our systems. All right, so breeze through that last section, but before I conclude and get ready for some questions, I want to bring us back to where we began. So I've made parallels between DevOps and platform engineering throughout this talk, and I hope it's obvious how important DevOps has been to this discipline, much in the same way that it has been for SRE, right? Our systems are complicated because people are complicated. And much like architecture design, this type of culture doesn't just happen, it requires intent. And the most compelling part of DevOps is ultimately the way that it transforms our culture to be one that fosters exactly that intent. And so I started off this talk by saying platform engineering is a solution to building sustainable organizations. But perhaps the solution that we really all just need is just intent. Thank you.